Hi everyone. So we are going to move on to the second part of our lesson, which is how to use the distance formula or how to find the distance between 2 points. So before we move on, I think that we need a quick review on how to simplify radical terms. You may have seen this in Algebra 1, maybe you saw this in the Lim 2 class. So what I mean, if you have a final answer and you get your final answer is the square root of 20, square root of 20 can actually be simplified further. And so for each one of these, we want to try and simplify by seeing if it has a perfect square that goes in there. So what is a perfect square? So for example, the square root of 4, square root of 4 is a perfect square because that comes out to 2. Why this pen is not writing? Because that comes out to 2. Same thing with the square root of 9. Square root of 9 is a perfect square because that comes out to 3. The square root of 16 is also a perfect square because that comes out to 4. The square root of 25 is a perfect square because it comes out to 5. Okay, so hopefully you have a sense of what a perfect square means. And essentially, each number that's under the radical, we want to try and break it down and see if, in fact, we have some perfect squares that go into it. So the square root of 20 is actually made out of two numbers that multiply into this. This is the same as the square root of 4. I'm trying to write a 4 times the square root of 5. Yes, it could also be square root of 2 times square root of 10, but the problem is neither 2 nor 10 is a perfect square like what we have here. So since square root of 4 is a perfect square, that means that the square root of 20 actually simplifies to 2 radical 5. Okay, let's try square root of 18. Square root of 18, I'm looking over here to see what numbers go into it. 4 doesn't go into 18, but 9 does, right? 9 times 2 is 18, so that means that the square root of 18 is the same as square root of 9 times the square root of 2. Square root of 9 is 3, so that means that this simplifies to 3 radical 2, because radical 2 does not simplify. Let's take a look at square root of 50. And see if any of these numbers go into it. 4 doesn't go into it evenly, 9 doesn't, 16 doesn't, but 25 does, right? 25 times 2 is 50. So we're going to rewrite this as square root of 25 times the square root of 2. Square root of 25 is 5, so square root of 50 simplifies to 5 radical 2. Now, taking a look at 53, 4 doesn't go into 53, 9 doesn't go, 16, 25. If I were to take this further, square root of 36 is a perfect square because this comes out to 6. Square root of 49 comes out to 7. But see, now we're getting to numbers that are like way too close to 53. And so none of these numbers go into 53 evenly, which means that this is already in simplified radical form. So pay attention to when you see numbers that could be divided by any one of these perfect squares, because that means that they can be further simplified when you're giving a final answer. Okay, so let's talk about the distance formula. Oops. Let's talk about distance. So you are actually going to find the distance when you're being asked to find the length of a line segment on a coordinate plane. Or if I want to figure out if the question says what's the distance between A and C, or what's the length of A and C, they're both asking for the same thing. So length and distance are the same exact thing as each other. Do you remember kind of what we were trying to do here when we drew a triangle? We went up and over. We're essentially going to do the same thing when it comes to, so wish me luck. We're going to do the same thing when it comes to finding the distance between A and C. So you can go up and over, right? And so we're going to just go down and over. We're going to make our triangle, and then we're going to count the lengths of the sides that we know. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I do that correctly? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I did. So this side length is 9. Then I'm going to count this side right over here. 1, 2, 3, 4, 5. So this side right here is 5. You should notice that when you do this up and over and create this triangle, this actually makes a right triangle. And there's something that you can do when you know two sides of a right triangle and you're looking for the third side. You can actually use the Pythagorean theorem. You can use a squared plus b squared equals c squared. The diagonal side, okay, so the long side, the side that you're looking for, the distance of is usually going to be c, so that's really, really important. So we can use, we are in fact able to use, oh my gosh, we are in fact able to use a squared plus b squared equals c squared. Okay, the only thing you need to know is that the side that you're looking for in distance is always going to be c. Okay, so let's actually do the math here. So a and b don't really matter. You can call one of them a, the other one b. So we're going to do 9 squared plus 5 squared equals c squared. Okay, so here's where we got to know our multiplication tables at some point. So a 9 squared is 81. 5 squared is 25, right? And this is equal to c squared. Add 81 plus 25 together and you get 106. Is equal to c squared. Okay, so now let's think about this. You want to get c. Okay, you want to get c. You essentially need to figure out how to get rid of the squared. The opposite of squaring something is square root, which means that we want to take the radical of both sides. So now we get the square root of 106 is equal to c, meaning that the distance is equal to 106. If it asks for you to do this as a decimal, then you're going to get this as a decimal, right? You're going to go to your calculator and you're going to actually figure out what the square root of 106 is equal to. And that actually happens to come out to like 10.3. So it just depends on how you're being asked to answer. This is 10.3 will be the final answer. Okay, and then you can kind of do the same thing here. So we're going to go over and up. It doesn't matter which. If you want to find the distance, you're going to create your triangle again, and then you're going to count. So this side is 1, 2, 3. Like we did this one before. Up is 1, 2, 3, 4, 5. Remember that the side that you're looking for is always c. So we're going to use our Pythagorean theorem. 3 squared plus 5 squared is equal to c squared. 3 squared is 9. 5 squared is 25. Right, so then we're going to add 9 plus 25 together, and you're going to get 34 equals c squared. Because you want c, right? We want c, we don't want c squared. We are then going to take the square root of both sides to get c by itself. And we get c is equal to the square root of 34. And we will get that as a decimal if need be. Okay, and the distance formula is as simple as that. You can use the Pythagorean theorem, or the other option is that you can actually use a distance formula. Okay, so you need to label your points x1, y1, x2, y2, and then you're going to plug into this formula. But notice it uses a square root also because it comes from the Pythagorean theorem. If you do x1 minus x2 instead, you can do that, but then you have to do y1 minus y2. The reason why you subtract between them is because you want to find the difference between the 2 points. Okay, so that is another option for us to find the distance is if you know what the points are. So this point is -2 up 1, 2, 3, 4. This point is -2, 4. Right, and this point right over here is 1, 2, 3, and then -1, 2, 3, 4, 5. So 3, -5. I can also use the distance formula to find this. So I'm going to use a different color pen. This is x1, y1, this is x2, this is y2. Okay, and so when I use a distance formula, I have the big square root, right, the giant square root. I'm going to do x2 minus x1, so that's going to be 3 minus a -2 squared plus, and then I'm going to do y2 minus y1. So I'm going to do -5 minus 4. And I'm going to square these, right? And check out what I get. 3 minus -2, that minus minus turns into a plus, so that turns into 5 squared. And -5 minus 4 is -9. Okay, and this turns into -9 squared. I'm going to leave in parentheses. These numbers look very familiar, don't they? Look how familiar these numbers look. So 5 squared is 25. -9 squared is -9 times -9, which is 81. This looks really familiar. And then you got a square root. Oh my gosh, we square rooted here. So do you see how you're going to get the same exact thing? So whether you do the distance formula or whether you do the Pythagorean theorem, they're both related to each other. So you should see some very, very similar numbers. Okay, so you can pick and choose what it is that you want to do. You can draw it out, or you can do the distance formula. Just make sure you're labeling correctly and that you are simplifying your final answer. Okay.